Hello and welcome to my presentation. My name is Isaiah Tan and I will be talking about Chapter 4 and Chapter 5 of Discrete Maths, which is Counting and Advanced Counting Techniques. This slideshow is divided into two parts, which is Part A and Part B. So, Part A we will be talking about permutations and combinations. Before we begin this chapter, we need to know about what is permutations and combinations. Firstly, permutations is an arrangement of elements in an order. This means that the order in which the elements are arranged matters. Secondly, combinations are an arrangement of elements where order does not matter. The elements in a combination can be placed anywhere in the range of elements. How do you apply them in real life? Permutations and combinations are often used in things that require combinations, such as creating passwords, optimizing delivery routes, creating car license plates, and determining seats arrangements. For example, first example, 5 race cars are racing on a racetrack. Calculate how many possible ways can the cars reach the finish line. Since there are 5 cars in the race, there are only 5 possible positions in which the cars can reach the finish line, which is from first place to 5th place. As you can see from the example here, we can find the possible ways by using factorial. The factorial is represented as an exclamation mark. So since there are 5 cars, we will use 5 factorial. And 5 factorial is equals to 5 times 4 times 3 times 2 and times 1. And this equals to 120 ways. So there are 120 ways where the 5 race cars can reach the finish line, in which the cars will reach in first place to 5th place. For the second example, there are 10 students in a competition. 5 students are chosen from the 10 to receive the prizes from first place to 5th place. For this one, the number of students is not equal to the number of possible places in which they will receive the prizes. So we will have to use this permutation formula, which is NPR equals to n factorial over n minus r factorial, where n represents the initial number of students, which is 10, and r represents the number of students chosen, which is 5. So if we want to find the number of possible ways, we can replace the variables with the values we have. So n will be equals to 10 and r will be equals to 5. If we put this in the formula, we will get 10p5 equals to 10 factorial over 10 minus 5 factorial. So 10 factorial will be 3,628,800, while 5 factorial will be 120. So after we divide, we will get 30,240 ways. So there are 30,240 possible ways where the 10 students are able to win the prizes. Now for the third example, there are 15 balls in total. 6 balls are red, 2 balls are blue, 4 balls are yellow, and 3 balls are green. How many ways can these balls be arranged? As you can see, we have 4 different colored balls in the 15 balls that we have. So we will have to use this permutation formula, which is Pn1, n2 and so on, equals to n factorial over n1 factorial times 2 factorial and so on. And that means we will have to replace each n variable in their respective order. Now we have 4 different colored balls, so we will need 4 n values and 1 more n for the initial value, which is 15 balls. So after we put them into the formula, we will get P6243 equals to 15 factorial over 6 factorial times 2 factorial and so on. So now, while we calculate all this, we will get 6,306,300 ways to arrange these 4 different colored balls. Good enough. Moving on to combinations, our first example will be a team of 6 people are chosen out of 20 people to be the new committee members of a club. So we will have to use this combination formula in order to find the 6 out of 20 people that will be chosen. So the formula is NCR equals to n factorial over n minus r factorial times r factorial. So as usual, we will replace the n and r with the values that we have. So n will be equals to 20 and r will be equals to 6. So after we put them in the formula, we will get this. Also mind that we will need to minus the numbers inside this bracket first before we times with the 6 factorial. So we will get 20 factorial over 14 factorial times 720, which is 6 factorial here. And then the answer, we will get 38,760 ways. So now we have 38,760 ways in where the 6 out of the 20 people will be chosen. Moving on from the previous question, our second example will be the same as the first, except there are extra requirements. As you can see, there are now 11 men and 9 women. It is to contain 4 men and 2 women inside of the community. So how do you find the number of possible ways they will be chosen, if you may ask? We can put them in a table form, so it will be easier for us to deal with this. So as you can see, there are 4 boxes for men and 2 more boxes for women. So if we put it this way, where 11C4 equals to 11 men and 4 men that will be chosen to be committee members, and on the other hand, 9 women will be put in 9 over here, and 2 women will be put inside here. So now we have 2 different combinations. So now how do we find it? We will multiply them together. So after you press the calculator or use the previous formula, you will get 330 times 36. So the answer will be 11,880 ways that the committee members will be chosen based on the gender requirements shown over here. Alright, we have finally reached the second part of my presentation, which is part B. So now I will be talking about recurrence relations. So what is recurrence relation? Recurrence relations is a situation where something repeats or returns in some time. It is also a sequence where each term is determined based on the previous terms. If you are not familiar with the Fibonacci rule, this is the explanation for it. So now, how do we apply this in real life? Recurrence relations are usually used for predictions and recognizing patterns, such as loan repayment and compound interest, designing algorithms, population growth, and procedural generation in games. If you know Minecraft, that's what they use. Here's another example of recurrence relations. Osman takes out a loan of 15,000 ringgit from a bank with 5% annual interest rate. At the end of each year, he repays the bank 1,300 ringgit. Find the loan balance that Osman has to pay after 3 years by using recurrence relations. So how do we find it? We will have to use the recurrence relation formula given over here, where AN refers to the original amount that Osman has to pay, which is 15,000 ringgit, 1.05 which refers to the 5% annual interest rate, AN minus 1 being the balance that Osman has to pay for each year he pays, and 1,300 ringgit being the amount of money he pays every year. So A0, which is referring to the original amount, is 15,000, so A0 will be equals to 15,000. A1 is the first year that Osman has to pay his loan, so it will be like this: 1.05 times A1 minus 1 minus 1,300. So if you see this A1 minus 1, that means it will become A0. So if you put it in the equation, it will become 1.05 times 15,000 minus 1,300. So after pressing the calculator, the answer will be 14,450 ringgit left for Osman to pay. So on the second year, we will be using the same method. So we will put in the first year's balance amount into the equation, and so we will get the second year's balance, and the third year will be using the same as well. So the total amount that Osman has to pay after 3 years is 13,266 ringgit and 13 cents. That's all for my presentation. Thanks for watching.